When sizing service conductors for a 200 amp main breaker without additional information, we must consider both primary and secondary conductors. For primary service conductors, you could use 4/0 American wire gauge aluminum or 2/0 American wire gauge copper. For secondary service conductors, 2/0 American wire gauge aluminum or 1/0 American wire gauge copper could be used. The selection between aluminum and copper depends on various factors, including cost, application, and local electrical codes. Always consult the National Electrical Code and local regulations for specific requirements and ampacity adjustments based on installation conditions such as ambient temperature and the number of current carrying conductors in a raceway. When choosing the conductor size, ampacity is the critical factor. Ampacity refers to the current carrying capacity of a conductor in amps. The conductor must be rated to handle at least the load it will carry, in this case 200 amps for the main breaker. The National Electrical Code Table 310.15b16 provides ampacity ratings for conductors based on their size, insulation type, and temperature rating. It is essential to use the correct table and apply any necessary directing factors. The length of the underground feeder, which is just over 200 feet, also becomes a factor because of voltage drop. Voltage drop is the decrease in voltage along a conductor due to its impedance and the current flowing through it. Excessive voltage drop can cause equipment malfunction and inefficiency. The National Electrical Code recommends limiting voltage drop to 3% for feeders and 5% overall, including both feeders and branch circuits. To calculate voltage drop, you can use the following formula: voltage drop equals 2 times K times I times D divided by circular mils, where K is the constant for the conductor material, approximately 12.9 ohm circular mils per foot for copper and 21.2 ohm circular mils per foot for aluminum. I is the current in amps, D is the one-way distance in feet, and circular mils is the cross-sectional area of the conductor. If the calculated voltage drop exceeds the recommended limits, you will need to increase the conductor size to reduce the resistance and minimize voltage drop. It's crucial to consider the insulation type of the conductors. Common insulation types include THHN, THHW, and XHHW. Each insulation type has a different temperature rating, which affects the ampacity of the conductor. The National Electrical Code Table 310.15b16 lists the allowable ampacities for different insulation types based on their temperature ratings. For example, THHN insulation is typically rated for 90 degrees Celsius in dry locations, while THHW is rated for 75 degrees Celsius in wet locations. The lower temperature rating of THHW means it will have a lower ampacity than THHN for the same conductor size. Underground feeder cable must be suitable for direct burial and wet locations. Underground feeder cable, often referred to as UF cable, is designed for this purpose. UF cable has a moisture-resistant outer jacket and individual conductors with moisture-resistant insulation. When installing underground feeder cable, it's essential to follow the National Electrical Code guidelines for burial depth. The burial depth depends on the voltage of the circuit and the location of the cable. For a 200 amp service, the cable typically needs to be buried at least 24 inches deep. However, the depth may be reduced to 18 inches if the circuit is protected by a ground fault circuit interrupter (GFCI), or if the cable is encased in concrete. Before installing any electrical wiring, it's crucial to obtain the necessary permits and inspections from your local building department. The building department will review your plans and ensure that the installation complies with the National Electrical Code and local regulations. Inspections are typically required at various stages of the installation, such as after the wiring is installed but before it's covered up, and after the installation is complete. Grounding is a critical aspect of electrical safety. The grounding system provides a low impedance path for fault current to return to the source, which helps to trip the circuit breaker and prevent electrical shock. A grounding system consists of a grounding electrode, such as a ground rod or a metal water pipe, and a grounding conductor that connects the grounding electrode to the service equipment. The size of the grounding conductor is based on the size of the service entrance conductors, as specified in the National Electrical Code Table 250.66. Bonding is another important aspect of electrical safety. Bonding involves connecting all metal parts of the electrical system together to create a common ground potential. This helps to prevent voltage differences between metal parts, which can cause electrical shock. Bonding is typically accomplished by using bonding jumpers to connect metal enclosures, raceways, and equipment. The size of the bonding jumpers is based on the size of the circuit conductors, as specified in the National Electrical Code Table 250.102. Overcurrent protection is essential to protect the electrical system from overloads and short circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. The size of the overcurrent protection device must be matched to the ampacity of the conductors it protects. The National Electrical Code Table 240.4b provides guidelines for selecting the appropriate overcurrent protection device size. When working with electricity, it's crucial to follow all safety precautions. Always turn off the power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and rubber gloves. If you're not comfortable working with electricity, it's best to hire a qualified electrician. It's crucial to consult the latest edition of the National Electrical Code, as well as local electrical codes and regulations, to ensure compliance with all applicable requirements. Electrical codes and regulations are constantly evolving, so it's essential to stay up to date on the latest changes. The authority having jurisdiction, OJ, which is typically the local building department or electrical inspector, has the final say on whether an electrical installation meets code requirements. Always follow the AHJ guidance and instructions. Furthermore, consider the environmental conditions where the conductors will be installed. If the conductors are exposed to extreme temperatures, corrosive environments, or physical damage, you may need to use conductors with special insulation or protection. For example, if the conductors are installed in a wet location, you should use conductors with moisture-resistant insulation. If the conductors are exposed to physical damage, you should protect them with conduit or other protective measures. In addition to ampacity and voltage drop, you should also consider the derating factors that may apply to the conductors. Derating factors are adjustments to the ampacity of a conductor that are required under certain conditions. For example, if multiple current-carrying conductors are installed in the same raceway, the ampacity of each conductor must be derated to account for the increased heat generated by the conductors. The National Electrical Code Table 310.15 provides derating factors for different numbers of current-carrying conductors in a raceway. Another derating factor that may apply is ambient temperature correction. If the ambient temperature around the conductors is higher than 30 degrees Celsius (86 degrees Fahrenheit), the ampacity of the conductors must be derated. The National Electrical Code Table 310.15b2 provides ambient temperature correction factors for different insulation types. When sizing conductors, it's always a good idea to oversize them slightly to provide a margin of safety. This can help to prevent overheating and voltage drop, and it can also provide extra capacity for future load growth. However, be sure to check with the AHJ to ensure that oversizing conductors is permitted in your area. When terminating conductors, it's important to use the correct type of connectors and to tighten them properly. Loose or improperly installed connectors can cause overheating and electrical failures. Use connectors that are listed and labeled for the type of conductor and the application. Follow the manufacturer's instructions for installing and tightening the connectors. Regularly inspect the electrical system to identify and correct any potential problems. Look for signs of overheating, such as discolored insulation or melted connectors. Check for loose connections and tighten them as needed. Test the ground fault circuit interrupters, GFCIs, and arc fault circuit interrupters are sized to ensure that they are working properly. If you find any problems, have them repaired by a qualified electrician. Remember that electrical work can be dangerous, so it's important to take all necessary safety precautions. Always turn off the power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment. If you're not comfortable working with electricity, hire a qualified electrician. Staying informed about electrical codes and best practices is crucial for ensuring electrical safety. Participate in continuing education courses and training programs to keep your knowledge and skills up to date. Read industry publications and attend conferences to learn about the latest developments in electrical technology. Network with other electrical professionals to share knowledge and experiences. By following these guidelines, you can help to ensure that your electrical system is safe, reliable, and compliant with all applicable codes and regulations. Remember that this information is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before making any electrical installations or repairs.